All right, folks, welcome back to AI Paper Podcast, where we take a deep dive into the latest and greatest AI research papers. And boy, do we have a fascinating one for you today.
Oh yeah, this one is a real doozy.
We're talking about DeepSeek's new model, Janus Pro, a multimodal AI making waves. But before we get into the nitty-gritty, we have to talk about the elephant in the room, right? DeepSeek, a Chinese AI startup, has been shaking things up lately, first with R1, their ChatGPT competitor.
Yeah, it seems like it came out of nowhere, taking the AI world by storm. And CNN reported that they developed it for a fraction of the cost of its US counterparts. Something like 5.6 million, a pittance compared to what? Hundreds of millions, even billions some companies have been investing.
Absolutely, it sent shockwaves through the market. NVIDIA stock, for example, took a noticeable dip.
It really makes you think. The US has been trying to, restrict China's access to high-powered AI chips. But DeepSeek managed to pull this off with less powerful hardware.
It's a real game changer, and it kind of makes you wonder if restricting access to these chips will really be enough to, maintain the current balance of power in the AI landscape.
Yeah, it's a question a lot of people are asking, but let's put a pin in that for a moment and focus on their latest release, Janus Pro. This multimodal model, it builds on their previous model, Janus, but it takes things to a whole other level.
So we're talking about a model that can understand and generate both text and images. We're talking recognizing landmarks in a photo, understanding text in an image, even grasping the narrative of an image.
Exactly. And then on the flip side, generating an image from, say, a complex text prompt.
A model fluent in pixels and words, so to speak.
That's a good way to put it. But what's really interesting is how DeepSeek achieved these results, especially considering those hardware limitations we talked about.
Yeah, so let's break down some of their key innovations. First up, their optimized training strategy. They basically simplified the pipeline, using a longer initial training phase on ImageNet rather than separating out training for, let's say, pixel-level understanding and complex image generation. Now, think about this for a moment. Could this simplification of what is usually a very complex process, could this be a game changer?
It's certainly a bold move. By front-loading that learning process with ImageNet, they're enabling faster and more efficient training overall. It's a really intriguing trade-off to think about. Does this more holistic approach, sacrifice some degree of specialization that you might get with more compartmentalized training?
It's a question worth pondering. And then there's their approach to data scaling. They didn't just feed Janus Pro a massive data set, they gave it a diverse one. We're talking captions, tables, charts, documents, even memes.
Yeah, like they wanted to immerse the model in the full spectrum of human communication.
Exactly. It wasn't just about object recognition, but understanding the nuances of visual and textual information. The real world is messy. It's multifaceted, right? Makes you wonder if down the line, we'll be seeing models trained on even more unconventional data sources.
Oh, absolutely. Things like social media feeds or even, sensor data. But going back to DeepSeek, they didn't stop at just data scaling. They also tackled a key issue from their previous model, Janus, which struggled with instability and had, frankly, kind of poor image quality, especially when giving shorter prompts.
Right. And so what did they do?
They went ahead and added a whopping 72 million synthetic images to the training data, with a focus on aesthetics, almost like they were trying to address the model's artistic shortcomings.
And finally, no discussion about model improvement would be complete without talking about model scaling. So DeepSeek, they went from a 1.5 billion parameter model with Janus to a 7 billion parameter model with Janus Pro.
A pretty big jump.
Yeah, and the performance comparison chart in the paper, it really shows the difference. It makes you wonder, is bigger always better when it comes to AI models? What are the drawbacks of these massive models? I'll give you a second to think about that.
It really is the million-dollar question, isn't it? You see, larger models, they do often converge faster, which gives you quicker and more stable results. However, you can't ignore the issue of computational resources. Training and running these behemoths requires serious processing power. And then there's always the risk of overfitting, where the model gets a little too comfortable with the training data and struggles to generalize to new information. It's like finding the right balance, between model size, performance, and those pesky resource constraints. But enough about that. Let's see how well this Janus Pro actually performs.
Well, according to the paper, Janus Pro is top dog when it comes to those multimodal understanding tasks. We're talking beating the state-of-the-art models on benchmarks like GQA, POBIT, MME, you name it. It even outperforms those much larger models like TokenFlow XL. What do you think? Why might the smaller, well-trained model be able to, outperform a larger one? Something to think about.
It just goes to show that bigger isn't always better.
Right.
Sometimes a more, focused and refined approach paired with those clever training techniques and carefully selected data, they can actually give you better results.
Right, so it's all about efficiency and elegance rather than sheer size.
Exactly.
DeepSeek is also making some, pretty bold claims about Janus Pro's text-to-image generation capabilities. Do those claims actually hold up when you look at the benchmarks?
It seems so. On the Geneval benchmark, Janus Pro 7B is hitting an impressive 80% accuracy, even beating out some of the big names, DLE3, Stable Diffusion 3 Medium. And on DPG Bench, which really focuses on a model's ability to handle those really detailed instructions, it scores a whopping 84.19.
Okay, so the numbers look promising, but numbers can only tell you so much. Let's take a look at Figure 4 in the paper. They've actually provided some visual examples of Janus Pro in action. There are examples of scene description, landmark recognition, even understanding a narrative that's depicted on a cake. And, well, the image generation is pretty impressive, especially when you consider that they're working at a relatively low resolution, 384 by 384. What stood out to you in these examples?
Honestly, I was struck by the level of detail, the realism that Janus Pro was able to achieve, even at that low resolution. The images, they're sharp, the composition is well balanced, and it seems to grasp, lighting and texture really well. It's clear they've made some serious progress addressing those issues with instability and image quality that plagued the previous model.
So when you look at these visuals, do you think the results match the claims that they made in the paper?
Okay.
Take a second to compare what you see with what they're stating.
I think the visuals speak for themselves. They back up DeepSeek's statements about Janus Pro's abilities. It's not just hype, there's actual substance behind the claims.
Now, even though Janus Pro is a huge step forward, the paper does mention some limitations. They point out that the input resolution is capped at 384 by 384, which could be a problem for things that require fine-grained detail like OCR or generating images with really intricate patterns. What kind of impact do you think this limitation will have on real-world applications?
It's definitely something to consider. This resolution might be fine for a lot of applications, but there are cases where higher resolution would be better. If you're doing things like generating high-fidelity textures for video games or images for, print media, then the resolution cap could be an issue.
They also mention that while the image generation is good, it could be even better with higher resolution, especially when it comes to capturing subtle facial features or those tiny details. Where do you think research is going in terms of addressing these limitations?
Well, the push for higher resolution and better fidelity, it's a constant in AI research. I think we'll see advancements in both hardware and software to help overcome these limitations. Maybe we'll even see new neural network architectures specifically designed for high-res inputs and outputs, or even new training techniques that use huge data sets of high-resolution images.
It's pretty exciting to think about all the possibilities that higher resolution and greater detail could unlock in areas like medical imaging, scientific visualization, and even art. But let's zoom out for a second and think about the bigger picture here. What does the emergence of a company like DeepSeek, achieving such remarkable results with, relatively limited resources, what does that tell us about the future of AI?
I think it shows that the AI world is changing fast. The playing field is leveling, with companies like DeepSeek showing us that you don't have to be a giant tech company with tons of resources to make breakthroughs. This influx of new players, fresh perspectives, it's likely to speed things up and lead to a more diverse and dynamic AI ecosystem.
You know what they say, a rising tide lifts all boats. Speaking of tides, how do you think the big tech companies are going to react to these new challengers? Will they shift their strategies?
I think we'll see a variety of responses. Some might try to acquire these promising startups like DeepSeek, bringing their talent and tech in-house. Others might double down on their own research and development, focusing on staying ahead through innovation. It'll be interesting to see how it all plays out. It's bound to have a big impact on how AI develops in the years to come.
It reminds us that in tech, if you're not moving forward, you're falling behind. But let's bring it back to Janus Pro for a moment and those innovations that made it all possible.
It's important to remember that Janus Pro isn't just about brute computing power. It's a result of clever engineering, meticulous data selection, and a solid understanding of the fundamentals of AI.
It shows how important it is to tackle these challenges with a mix of technical skill and creative problem solving.
Right. Innovation often happens when different disciplines come together.
And one of the most clever things about Janus Pro is its decoupled visual encoding architecture. It's a departure from the traditional way of doing things, which uses a single encoder for both understanding and generation tasks. Why do you think they decided to go with this kind of architecture? What are the benefits?
It's a pretty smart move. They recognize that the best features for understanding an image aren't necessarily the same ones you need for generating an image. By using separate encoders, they allow each encoder to, well, specialize, which eliminates that compromise you get with a shared encoder.
So it's like having dedicated teams for each task, right? What implications do you think this decoupled architecture has for future multimodal models? Could this become, a standard design? Think about it for a second.
It's an idea worth exploring, for sure. The decoupled architecture gives you a level of flexibility and potential for optimization that could be very useful as we push the limits of multimodal AI. I wouldn't be surprised to see this design becoming more common as researchers try to create models that can seamlessly integrate different modalities, text, images, audio, even sensory data.
It's giving each modality its own lane, so to speak, right? Allowing the model to process and synthesize information in a much more effective way. But the decoupled architecture, it's really just one piece of the puzzle. DeepSeek also made some really big strides in optimizing the training process itself, making it much more efficient. And of course, we can't forget their data scaling strategy, bringing in all sorts of modalities into the training data, from text and images to tables, charts, and even memes.
It all comes back to that idea that a model is only as good as the data it's trained on, right? By giving Janus Pro such a rich and diverse data set, they've enabled it to develop a much more, robust and nuanced understanding of the world. And let's be honest, the world is increasingly blending the visual and the textual.
Right. And it makes you wonder what's next for data scaling. Will we see models trained on entire libraries of video content or even real-time sensor data streams that capture what's happening in the physical world?
The possibilities are pretty mind-blowing. As we move towards a world that's even more interconnected and data-rich, the real challenge won't be just collecting and storing this data, but developing AI systems that can actually make sense of it all. Systems that can navigate that complex interplay of modalities that shape how we experience reality.
And that's exactly where innovations like Janus Pro come in, paving the way for a future where AI isn't just about numbers and patterns, but about truly understanding and interacting with the world and all its messy multimodal glory.
It's a future with a ton of potential, but also some significant challenges. As AI gets more sophisticated and more integrated into our lives, we have to think about the ethical implications. We need to make sure these powerful tools are used responsibly and for the benefit of everyone.
I completely agree. It's a conversation that needs to involve everyone, not just researchers and developers, but policymakers, ethicists, and really society as a whole. But for now, let's take a step back and appreciate what DeepSeek has accomplished. A relatively small startup shaking up the AI world, pushing the boundaries of what's possible, and reminding us that innovation can come from anywhere.
It's a good reminder that the pursuit of knowledge and the drive to create, they're universal. And the future of AI, it's going to be shaped by a lot of different voices, perspectives, and approaches.
Well said. And on that note of hopeful anticipation, we're going to wrap up this episode of AI Paper Podcasts. Make sure to check out the show notes for links to the Janus Pro paper and project page. We'll be back soon with another deep dive into the latest breakthroughs in AI research. Until then, keep exploring, keep asking questions, and keep pushing the boundaries of what's possible in the world of artificial intelligence.